a good strategy that you can use for converting concentration units, if you're converting within the same type, okay, then all you really have to do is assume any value for either the denominator or the numerator in your defining equation for the concentration. For example, let's say you knew the molarity. Okay, so what's the definition of molarity? It's moles per liter, right? Moles of solute per liters of solution. Okay, so let's say you knew the molarity, then you can assume either an amount for the number of moles or an amount for the volume in liters, and you can figure out the other. So if I know the molarity, and if I know one of these two, if I know mole solute, then I can figure out liters of solution. If I know liters of, if I assume the value of the liters of solution, and I know the molarity, and I can figure out the moles of solute. Okay? So you can assume any value for either the numerator or the denominator, and then use the defining equations to figure out the other one. And then all you have to do is convert these amounts to whatever amounts you need to do to figure out the concentration in whatever unit you want. Let's illustrate that with this. Vinegar is 5% weight by volume, acetic acid in water. This is acetic acid, CH3COOH. Let's calculate the molarity. Well, what's the defining equation for this? So we know the 5%, okay, weight by volume, okay. So that's one. What's another way of expressing 5% weight by volume? Now you say that is 5.0 grams CH3COOH, okay, per deciliter of solution, right? It's your concentration per deciliter of solution. So what did we say we were going to do? Assume that we know the numerator or the denominator, right? So this is equal to mass. In general, that's the mass of acetic acid over the deciliters of solution, correct? So what would be a good number to assume to make calculations simple? Assume a number like 1 or 100. Okay, so let's assume you have 1 deciliter or 100 mils. Okay, so let's assume we have 1 deciliter of solution. So that's the volume of the solution. Okay, so the volume of solution. How many grams of solute do you have? 5, right? So then the amount of solute is 5 grams, CH3COOH. Okay, so we say in other words, what we're saying is percent weight by volume is equal to mass over volume, right? Mass of solute over volume of solution in deciliters. Okay, so we know this. We assume we have 1 deciliter of solution. We figure out what the mass would be, 5 grams. So given this, I can figure out molarity, right? How do I figure out molarity? What's the definition for molarity? Molarity is mole solute over liters of solution, correct? What's my solute here? Acetic acid, right? So how do I convert 5 grams to moles? Grams to moles, what do? You use the molar mass, you divide by the molar mass. So times 1 mole over molar mass of acetic acid is 60.06 grams per mole. So that cancels out grams. So I just changed my moles of solute to my grams of solute to moles of solute. And what's the volume of my solution? 1 deciliter, right? Which is the same thing as what? 100 mils, right? So this is 100 mils. But what should I do with my 100? I have to 100 mils. I have to change that to liters, right? So I'll change that to liters. So 1 liter is how many mils? 1,000 mils. So that gives you your molarity. So what's your molarity then? 5 over 60.06 divided by 0.1. Okay? What would that be? Let's see. Calculator. You have 5 divided by 60.06 divided by 0.1. Okay, 100 over 1,000 is 0.1. So this is 0.833, 0.83 moles per liter. Okay, why am I only keeping 2 sig figs? I only have 5.0 here. Okay, 2 sig figs. So my answer should have only 2 sig figs. If I assumed I had 2 liters of solution instead of 1, then I would have figured that I'm going to have 10 grams of acetic acid, right, instead of 5. And then what I'll have when I do my molarity is I'm going to have 10 over here instead of 5, but then I'll have 200 down here instead of 100. So I end up with twice as much in my numerator and twice as much in my denominator. I'm still going to get the same answer. The thing to realize about your concentrations is they're a ratio of 2 things. So it doesn't matter how much you assume for your numerator, your denominator will just follow suit. If you have twice as much in your numerator, your denominator is going to be twice as much. The ratio will still be the same.